It's me, Bella, and I'm going to be talking about the magnetosphere and the Van Allen radiation belts. So, what is the magnetosphere? Well, the magnetosphere is an invisible area around our planet that contains Earth's magnetic field. This is how NASA believes the magnetosphere might look like from above. Cool, huh? But first, it is very important to know about the Earth's magnetism. The Earth's magnetic field is like a bar magnet inside the center of the Earth. Every bit of matter is made of tiny particles called atoms, which are little groups of electricity. Atoms have negatively charged electrons, which are like tiny pieces of electricity that spin around them. They usually go crazy in random directions, but every once in a while, they will all get together to spin in the same direction. When this happens, they create an invisible force called magnetism. To understand Earth's magnetism better, you have to understand how magnets work. Magnets, like this horseshoe magnet, make an invisible area magnetic force all around them called a magnetic field. If you push a magnet closer to iron nails, there will be a point where the nails will jump across and stick to the magnet. The nails are within the magnetic field and are drawn to it. The Earth's core is filled with iron and nickel, so the Earth acts like a great big magnet, generating a huge magnetic field around the planet. This protects Earth from blasts of harmful radiation that comes from the sun. Occasionally, a part of the sun will suddenly release a large amount of energy and electromagnetic radiation. This explosion is called a solar flare. It can be more powerful than 1,000,000 nuclear bombs. The energy from a flare travels through the space and at very high speeds. What? Hot! Since the Earth's atmosphere is strongly magnetic, it protects us from almost all solar storms. When the gas particles are released from the sun, they come in contact with the gases of our atmosphere. The different colors produce what are called the aurora borealis and aurora australis. Solar storms can affect astronauts and satellites that are outside the protection of our atmosphere in really crazy ways. In 1958, scientist James Van Allen led the team that launched the first successful satellite that could detect radioactive particles in space. This satellite was Explorer 1 and led to the discovery of the radiation belt, named the Van Allen radiation belt. The Van Allen radiation belts are two donut-shaped belts located in the magnetosphere. They are a result of the Earth's magnetic field. The magnetic field traps particles, making them move faster and forming belts of radiation. The belts begin about 8,400 to 36,000 miles above the Earth's surface. These belts are filled with electrons and charged particles, the material called plasma that surrounds the Earth. Both belts swell and shrink. The inner belt is made of mostly protons, with a small amount of electrons, making it stable most of the time. The outer belt is filled almost entirely with accelerated electrons. The Earth's ionosphere swaps particles with the outer belt and also gets particles from the solar wind. On August 30th, 2012, two robotic spacecrafts called the Van Allen probes were launched to study the radiation belts. Scientists are still learning many new and exciting things from the probe. This animation shows how particles move through the radiation belt. The circle in the middle shows a cloud of colder material called the plasmasphere. New research from NASA shows that this helps keep fast electrons from the radiation belt away from Earth. Why is it important to study the Van Allen radiation belt? Studying the belt can help scientists use what they learn to build better spacecraft and satellites, plan missions better, and keep astronauts safe. It will also help scientists predict how solar storms will affect the Earth and may allow advanced warnings in case electronics need to be shut down to protect them from radiation. Science can also learn more about plasma, which they do not fully understand. Thank you for watching and listening to my slideshow today. I hope you learned a lot. I know I did.